So we can have three different scenarios where we have no triangle, one triangle, or two triangles. Now, when I draw the law of sines when it's given side-side angle, I always make sure that I draw my angle at the bottom left and then my side and side, just like these three pictures are oriented here. I find that easier to manipulate when we get to the two triangles. You are welcome to try and reorient it differently. I just like this way the best myself, personally. Okay. So we go about our problem the normal way that we go. This should say angle A. I just didn't interpret it right. So what we're going to do here, I'm going to draw myself a picture so I can orient myself. So here's my 50 degrees. That's angle A. Across from angle A is side A, so that's 10. And then side C is 20. So notice I've got an angle side side. So when I have the angle side side, I've always got it set up so I've got the angle on the left, the side, and then the side. Okay. Again, that's personally how I do it. You can reorient it, however. Now, I don't need my triangle to look perfect, but notice I did make an acute angle here. So if this is side C is 20, then that means that this is angle C, and this would be angle B. Now, I didn't finish making the triangle because I'm not sure if it makes a triangle yet. So I'm just going to set up, remember our law of sines is really A over sine A equals B over sine B equals C over sine B, or you can have all three of those flipped. I personally like it where the side's on top. So here, notice we've got our side and an angle across from each other, and then we have the other side and the angle across from each other that I want to use to help me solve. So I'm going to set up my proportions so that I have 20 over sine C equals 10 over sine B. Not sine B, sorry. 20 over 10, that's a 10. Sorry, over sine 50 because we know the angle. So this one matches this one, and this one matches that ratio. So then notice that I can just cross multiply here. So multiply these two. So then I end up with 10 sine C equals 20 sine 50. Now I could put this in my calculator and start solving, but I'm just going to, before I do anything in my calculator, I'm just going to get the sine C by itself. So, sorry, I was saying sine C, but I wanted to write 10. So to get the sine C by itself, I have to divide by 10. So then I'm just going to make sure, first of all, that my calculator is in degrees, because we're in degrees, so make sure you check your mode is where you check that. Or if you're on like a phone calculator, you look for rad or deg for degree. So you do 20 sine 50, make sure you close your parenthesis after the 50, and then divide by 10. And then that gives us that sine C, not just C, sorry. Sine C is 1.532. Okay, so now if we want to undo sine, that means we have to do the inverse sine. So I'm going to take the inverse sine of both sides. Remember, we represent the inverse sine with a negative 1 power. It's not, you're not multiplying those, it's an actual function that you're taking. So if I do the inverse sine of that, so in my calculator I'm going to do second sine second answer, because the 1.532 is sitting in my calculator, and that way it is more precise. And then notice it gives you an error and says domain. That's because your sine values only go between +1 and -1, and this is outside of that, so it's not in the domain. Okay. So if you get an error like this, first make sure that the math up to that point is correct, and then if you get an error like that, that means that there is no triangle. So this side is too short to make a triangle. Okay. So that's our first case that we have. So if we have this triangle, notice this one is drawn for us, so you can either have it drawn or they give you the information. The last one they gave us the information, this one is drawn. So notice I've got the angle, the side, So I'm going to set up my two proportions. So I have an angle and side across from each other. Remember, that is the important part of law of sines. The side and angle across from each other and another side and angle across from each other. So we have a side and angle across from each other, so I'm going to set it up. So I do 33 over sine 57 equals 26 over sine B. So that So those match, just so you can visually see. So I'm going to cross multiply again. So when I cross multiply, I end up with 26 sine 57 equals 33 sine b. Right? Well, I'm trying to get sine b by itself, which means I need to get rid of everything outside the sign. So the 33 is outside the sign, it's being multiplied. So I'm going to undo multiplying by dividing. So again, I'm just going to put this whole thing in my calculator. I need to make sure that I close my parentheses around 57 and that your mode in your calculator is in degrees. So 26 sine 57 close parenthesis divided by 33. So that gives us 0.66077, and it keeps going for a while, equals sine b. Well, we don't want sine b, we want b. So we need to undo the sign. Well, we undo the sign with the inverse sign. We put the inverse sign on the left side of both of them. It's kind of like how we put square roots on the left side. So when I do this in my calculator, I'm going to do second sign, second answer, so that it uses the whole thing so I don't get a rounding error as I'm going. So then when I plug that in, it gives us 41.359. Okay. So now I skipped over this part. If we look here, I'm going to erase this so that you can see it fine. Okay, but this is the important piece of information that we want. So once you find that angle, the B angle that we just found, if that angle that you just found is less than the given angle, there's only one triangle. There is one exception. If that angle that you just found is 90 degrees, then there's only one triangle. Okay? If you try to find the second triangle, it'll be problematic. So notice here, that angle that we just found is 41, so we're looking at 41.359. So if that angle that we just found is less than the given angle, so we want to know, is that less than 57? Yes, this is true. So if that's true, then there's only one triangle. Okay. So then you can just finish solving that one triangle. So we know that this one, for sake of not having a lot of things in the picture, I'm just going to put this as 41, right? Which means that now I can find my angle C, right? Using that there's 180 degrees in a triangle. So I do 180 minus the 41.359 minus the 57. And when I go to my calculator, I am going to use second answer because I have the 41 point whatever sitting in my calculator so that I don't get a rounding error. So 180 minus second answer minus 57. So then angle C is 81.641. Okay. So now we have this piece of information. Again, I'm just truncating the numbers so that I can see visually on my picture. Well, we're only missing this last side. So if I want that side here, I can use this proportion to help me out with that. So you can use the one that you just found, but then you are using a decimal, so I prefer not to use that because then I could end up with a rounding error. So instead, I'm just going to set it up so that I've got, I'm going to come up here and set it up. So we've got the orange one that we're looking at, so the 33 over sine 57 equals, and then I'm going to do the side that I'm missing, so that's little side C, right, across from the angle, we call it the same letter, just lowercase, so C over sine 81 point whatever 641. Okay. So again, I'm going to cross multiply. So when I cross multiply here, we get 33 sine 81.641 equals C sine 57. And this time we're trying to get C by itself. Well, if I want C by itself, I want to undo the timesing by the sign. So I'm going to divide by sine of 57. So I'm just going to put this whole left side in the calculator here, making sure that I close my parentheses. Now, when I plug this in, I'm going to do 33 sine, but then I'm going to use second answer for this part because it's sitting in my calculator. So that way I avoid a rounding error. Make sure to close my parenthesis, then divide by the sine of 57. So then that gives us that C is 38.93. Okay. So then notice I've got all of my missing pieces of information. Okay. Now, what happens when there are two triangles? So let's take a look at that one. What happens with two triangles is that you end up with this side here that can swing in. So these two are the same side, so you either get this triangle here, or you get this triangle here. Okay, so that one matches. Okay, so those are your two triangles. So the blue triangle, blue isosceles triangle, we don't actually care about that triangle. We only care about it enough that it helps us get to the rest of the orange one. Okay? So let's take a look. So this was supposed to be an angle measurement like that. So I'm going to draw 40 degrees. Again, I'm just estimating. I'm just making it cute, nothing fancy. Across from angle A is side A, so 54. And then side B is 62. Okay? So if I find this angle, this was B, so that means this side has to be B, which means that angle is C. So I'm just going to set up my proportion. Again, you're just looking at the side and angle that you know, and then a side and an angle that you want. So we're going to set it up so that we do 54 over sine 40 equals 62 over sine B. So again, I'm going to cross multiply just like we've been doing. So we have 62 sine 40 equals 54 sine B. Well, I want the sine B alone, so I'm going to undo timesing by 54 by dividing by 54. I'm going to put this whole thing in my calculator, making sure to close my parentheses after 40. So 62 sine, and making sure that your mode is in degrees. Okay, so I get 0.738 equals sine B. Okay. So I'm going to undo the sign. Again, we undo the sign with the inverse sign. So I'm going to do the inverse sign of both sides. The inverse sign undoes the sign, so these cancel, so we're left with B equals, and then if I do, again, I'm going to use second answer in here. So second sign, second answer. So that gives us 47.56. Okay. So B is 47.56. We'll go one more decimal. Now, I'm going to store this in my calculator. When we're storing a number in a calculator, you use the button STO, that's off the bottom left, just above the on button if you're on a TI calculator. So I'm going to hit store, and notice it'll say ANS, and then it has a little arrow, and then you want to store it to a variable. So I'm just going to store it to X, because we're going to use that in a minute, and then that way I don't get a rounding error. So first of all, we know that this triangle is an actual full triangle, right? And we know that this one is 47. Okay. So what we're going to do is we're going to create this triangle picture here to help us out. Right? So we know that this is 40. We know that this is 47. We know those two are the same sides. That's the side that we're swinging in. That's our third given side. This angle right here is not given, so it can change. That's why we can swing that side in. Okay? And again, remember, we know that this is 62 and 54. Well, we have this triangle right here is our isosceles triangle. Well, if it's isosceles, this is like the problem that we did at the beginning. That means that these two angles are congruent. So this is the 47 point whatever. Okay. So again, if we label this is A, this is C, and this is B. So I'm going to call this B1. So I'm going to go and I'm going to subscript this and say that's B1. So this angle right here I'm going to call B2 because it's our second triangle that you could have that's angle B. Well, if we know that this angle is 47 point whatever as well, these make a linear pair. So I can find B2 by doing 180 minus the 47.563. So I can do 180 minus, and you can either do X or second answer in your calculator. So then you get 132.437. So this is 132. Okay. Well, if I want to find this yellow angle here, that means, so I'm going to call that C2. So angle C2 is going to be 180 minus the 132.437 minus the 40. Now, perhaps you found one and you thought that you had two triangles. If you get to this point and you get a negative number, that means that there's not two triangles and there's only one triangle. So that's a secondary way that you could do it, but that's a lot more work rather than just checking the angles once you found that angle. So we're going to do 180 minus 40 minus either second answer or x again. So angle C2 is 7.563 when I round. So I'm just going to call that 7. Okay. Well, now I can set up. I still have this side length that I know, but I also have this one that I can use to find side C. Right? So I'm going to set up yet another equation, and we're going to do 54 over sine 40 equals, and we have the angle C2, but we don't have the side C2. So little c2 over sine of 7.563. Okay, so I'm going to cross multiply again. So we have 54 sine 7.563 equals C2 sine 40. Well, I want the C2 by itself, so to get the C2 by itself, I need to divide by sine 40. So I put that in my calculator, so 54 sine, and then I'm going to use second answer so that I don't get a rounding error. Close your parenthesis after that, and then divided by sine of 40. And that gives us that we have C2 is 11.056. Okay, so that means this little side right here is the, oh, I guess it's that side. Gray was showing the proportion. So this is 11.056. But if we go back and we look at our triangle, I still am missing the green angle that we have, this one right here, still missing that full angle, and I'm still missing this side of the whole thing. So what I'm going to do is I'm going to go back and I'm going to think about the big triangle that we have. So let's see here, this triangle that we have. Right? So I'm going to redraw that off to the side. Right, so we know this is 40, this is 54, this is 62, that was the 47 point whatever, which means I need to find these two pieces of information, right? Well, this was A, this was C, this was B. This was B1 that we found, so this will be C1, so this will be little c1. So I'm going to set up my proportion yet again. We've got another set of proportions that we're going to look at. So we're going to do 54 over sine 40 equals, and then I want to do my proportion for my C values. So I'm going to do this one. So we do C1, which we were looking for, over sine of C1, the angle, which we didn't actually find yet. So let's find angle C1 first. So 180 minus the 40 minus the 47 point whatever, which is sitting in our calculator as x. So 180, that's why we store it, so that we don't get a rounding error on one of our triangles. So minus the x. So that gives us that C1 is 92.437. So this is 92. Okay. So then sine 92.437. So yet again, we're going to cross multiply another time. So when I cross multiply here, we're going to get 54 sine 92.43 equals C1 sine 40. Well, again, I'm trying to get the sine, or the C1 by itself, so I want to undo the sine 40. So I'm going to divide by sine 40. And I'm going to put this in my calculator, but I'm going to use second answer for the 92 point whatever, because that's what's sitting in my calculator. So 54 sine of second answer, close your parenthesis, and then divide by sine 40. So then we get 83.933 equals C1. So that means that this, oh, I can't scroll up. Good thing I have it over here. This is 83.933. So that gives us all of our missing pieces of information that we have. So the way that I remember that you need to do to check if there's two triangles is because you're given an angle, you're given a side, and a side. This is a pain in the ass to do. Angle, side, side spells ass. You only have to check it for angle, side, side. That's the only one you need to check it for, not any other ones. All the rest of them are just normal, and there's nothing abnormal about them. Okay, so that's what you need to keep in mind when you are doing the law of sines with angle, side, side, or side, side, angle.